Welcome to How to Calculate a Trimmed Mean. For our first example, we're going to look at the snow cover for Eurasia during the years 1970 and 1979 in million kilometers square for a sample of 10, and this is our data. Now, we know how to calculate the mean and the median. So here is the mean and the median for this data set. Now what we're going to do is we want to calculate the 20% trimmed mean. So the first thing we want to do is we want to put our data in ascending order. And in fact, to actually calculate the median, we would have had to have done this. So let's put our data, or see our data, in ascending order. So we're putting our data in ascending order. The next thing we need to do is to determine how many data points, and I'm going to call that number K, constitutes 20% or 0.2 of your sample. That is to find out what 20% of our sample size. Now our sample size here is 10. So remembering that 20% can be written as 0.2, and we're going to say we're going to let X be that value, that 20%, the 0.2 of our data. So we need to find out what K is. So K is basically n our sample size times the 20% written in decimal form. So in order to find K, I put in our sample size of 10, I multiply that by 0.2, and I would get 2. So that means I have to trim off 2 data values from the top and bottom of our data set. So since our K is 2, once again, what does that mean? We take our data set and we have to trim off 2 data points from the top end, that you see right here, and 2 data points from the bottom end. So we have to now take the mean of this middle data right here. So we have 6 points left. So we got to take the mean of these remaining 6 points. And when we do that, we just add up the numbers, divide by 6, and we get 11.483. So rounding to 2 decimal places, our 20% trimmed mean would be 11.48. Now something to be aware of. Trimmed means seem to have a different meaning to different people. If you just perform a Google search for trimmed mean, you'll find some people will state a trimmed mean of 10% is where a total of 10% of the data is removed. That is 5% from each end, as opposed to trimming 10% from each side. So in our example, for the 20% mean, they would say you need to trim 2 data values. So they would just take 1 from the top end and 1 from the bottom end. So be very careful. That's not the usual meaning of a trimmed mean. So your instructor or boss will likely use the term exactly as I've demonstrated here, because this is generally the understood meaning of a trimmed mean. But you may want to clarify before you actually do calculations in another class, or if you're asked to perform a trimmed mean at work. Now let's take a look at another example where things aren't so nice. So this time we're going to look at 12 data points, and we want to calculate the 20% mean. Now again, we know how to calculate the mean and the median, and this time our data set is already in ordered form, so it's easy to see the mean, and the median would be the middle 2 data points, their arithmetic mean, to give us that median of 11.95, where the mean is 12.01. So how do we calculate the 20% trimmed mean in here? Well, as I said, we already have our data in ascending order, so 1 is already taken care of. 2, calculating the K, finding out what K is. But this time K is 12 times 0.2. So again, number 1, there's our ascending order. Now to determine K, remember what K is. It's our sample size times that trimmed mean, percent trimmed mean. So I changed my percent into a decimal. So again, X would be 0.2, and I multiplied 12 times 0.2. But this time I don't get an integer, I get 2.4. Now I want to say that there are more accurate ways to get the 20% trimmed mean from our data set, but we're going to use the method that I'm going to show you. There's going to be two options here. I'm going to trim 2 data points and actually get a new trimmed mean, or 3 data points to get another trimmed mean. In other words, I can't get exactly 20. If I use 2, I'll have another trimmed mean, and we're going to find out that's going to be about a 17% trimmed mean. And if I trim 3 data points, we're really getting about a 25% trimmed mean. So let's see how that looks. So again, since k is an integer, we got that 2.4. I can either trim 2 data points from the top and bottom, or 3 data points from the top and bottom. So let's look at option 1. If I trim 2 data points, then what trimmed mean am I really getting? Well, I would take 2 divided by 12 to find that percentage. 2 divided by 12 is about 17.17. So if I trim off 2 data points from the top and bottom, that's a 17% trimmed mean. So looking at option 2, trimming 3 data points from the top and bottom of our data sets, what trimmed mean are we actually getting if we trim off 3 data points? Well, I take 3 divided by 12, and that would be about a 25% trimmed mean. And in fact, that would be a 25% trimmed mean. So you'll have to choose which method you want to use, whether you want to go with the 17% trimmed mean or the 25. So let's look. If we choose option 1, what would be our trimmed mean, our 17% trimmed mean? Well, if I choose option 1, that means I'm taking 2 data points from the top and bottom of our data set. So in red, I've shown you the 2 data points on the top and bottom. And so now I take the middle data points that I have there. There's 8 of them. I take those 8, I add them up, divide by 8, and I get the trimmed mean of 11.612. So 11.612 is approximately the 17% trimmed mean, because we couldn't quite do the 20%. What would it be if I chose option 2? That is taking 3 data points off of the top and bottom of our data set. So for option 2, determine the mean of the remaining data values. Well, if I trim off 3 off the top and bottom, I'm left with the 6 middle data values. I add them up, divide by 6, and I get 11.533. So 11.533 is the 25% trimmed mean. And that's how we would work with trimmed means if our k, or the number of data values we take off the top and bottom, didn't end up being an integer when we found out that percent trimmed mean with our particular sample size. Well, thanks so much for watching.